did learn that we were learning about some of the methods using which you can find the HCF of a given number. So for example, we did learn about the first method of finding HCF, whereby you can simply list out all the given factors, and then thereby you will now find out which one of them is the highest value. We had some examples like this one, where we had taken examples of some numbers, and then we found out which one of them is highest in value, thereby that becomes the factor of the given number. We did learn to found the factors, HCF of two numbers, and in fact more than two numbers also, their HCF also can be found out. Okay, now so first of all, we're going to practice some questions on that, then we would be continuing further. Also turn your camera on in the class.
Sir, it's on.
It's on. Okay, just give me a moment. Let me. Hmm. So in the beginning, we did learn about how you can find out the HCF of given two numbers or even more than two numbers just by listing out all the factors. So let us quickly revise this concept. So say I'm giving you two numbers, 82 and let's take another number as 32. So you're required to find out the highest common factor of the given two numbers. So we know, first of all, using the first method, you have to simply list out all the given factors. The factors of 82 is going to be 2. 2 is a factor of 82, right? After 2, which one is the factor of 82? Yes, think of this. Is 3 a factor?
No.
No. Is 4 a factor? No. Neither is 5 right now. So after 2, we get to see that the number 41 is the next factor of 82, right? And then after this, we have the number 82 itself. These are the factors of 82. Talking about 32, there are many factors of 32. Like 2 is a factor of 32, 4 is a factor, 8, 16, and the number 32 itself. So here we find out that the only factor which is common is 2 for both these numbers, and in fact, this will also become the highest common factor because we don't have any other factor. So this becomes the HCF of the two number. Getting it what I'm saying?
Yes.
Okay. Furthermore, we learned that if we were to have more than two numbers, so their highest common factor can also be found out very easily, right now. So say you have taken two numbers like 32, you have taken, let's say, 56, and let us say we have the number 86. These are the three numbers which we have, and we are required to find their highest common factor using the first method. Using the first method of listing method. The first method was by listing the factors. So using this, first of all, let us write all the given factors of the numbers. So what are the factors of 32 again? Yes, Abhi?
2, 4, 8, 16, and 32.
16 and 32. What are the factors of 56?
1.
Okay, 1, we can take 1 also, good.
7.
2. After 2, you'd be having 4 now.
1, 2, 7, and 8.
No, 4, you missed 4. 4 14s or 14 fours are 56. Okay, no? Yes, 7 and then
8.
8 and
56.
you forgot 14 and 28 also, then 56. Okay, talking about 86, 1 is its factor, 2 is its factor, then after this,
Sir, I came.
oh, I didn't notice. Yeah, Sumaya, how are you? Assalamu alaikum. Yeah, Sumaya, how are you?
Hi.
Okay, right now we are learning about the HCF which we were doing in the previous class. So we are quickly revising this via some examples. Okay. So we did learn about how to find HCF of two numbers using the first method where you would be simply writing down the given factors and then find out the HCF. So we have taken three numbers. So using the first method of HCF, how you can find out the HCF of three numbers. So write down the factors of 86. One is a factor, two is a factor, and then which is the next factor? Is 3 a factor of 86?
No,
No. 4?
I guess yes.
No, 4 is not a factor, no? 4 is not a factor. 4 does not completely divide this. After this, you'd be having the number 43. This is the factor of 86 after 2, okay? Then after this, the number itself, that is 86, is its factor. So here we find out that it has only one common factor, that is 2. Is there any other common factor? Is there any other factor? We have
Yes. No, no.
4 also. 4, no. 4 is only for 30 and 56. So what do we observe here? That this number 2 will become its HCF. Okay, now let us change the numbers now. What if in place of 56 we had a different number? Hmm. In place of 56, let us take another number. How about we take a number 16? Okay. You guys tell me what are the factors of 16 quickly?
1, 2, 8,
You missed one number.
4,
Yes.
4.
4. Sumaya, you also have to answer. Then?
Then 8.
And
Then, yeah, 16.
16. Okay. Now you guys tell me which is the highest common factor now.
4.
That is 4. Very good. Okay, now. But you guys missed one more number. First of all, you have to circle the common factors. No? 2 is a common factor. Okay.
8, 8.
4 is a common factor. Very good. 8 is another common factor here.
Yes, is
So
8.
thereby HCF is 8. So hope that much is clear. Right. So this was the HCF of multiple numbers. When you have two or more than two numbers, by using the first method, you can find out the HCF of a given number. Okay, now like here also we have another method we should be learning in a minute. Okay, now. So HCF, finding the HCF by listing the factor method we have learned. Okay, and you can find out the HCF in this manner for two or more than two numbers. Right, then we did also learn about how we can find out HCF by prime factorization method also. Okay, na? So hope you guys did learn about that also, right? So HCF can be found by prime factorization method also. So Habib, please read the given paragraph. First of all, read the first paragraph quickly.
So the yellow one or white?
The white one.
HCF by prime factorization. In order to find the HCF of numbers by the prime factorization method, we use the following steps. Let us understand this method using the examples given below. Step 1. Find the common prime factors of the given number. Step 2. Then multiply the common prime factors that have the least or smallest power to obtain the HCF of those numbers.
Good. Sumia, you read the next paragraph. Not the next paragraph. Like basically, let us do some more questions on this. In the previous class, we did have learned via some examples. Like we had the example of 60 and 90. We did write them in the form of their prime factors as the product of their prime numbers, right now. So 2 times 2, 4, 4 times 3, 12, 12 times 50. That gives you 60. Right. So the number 60 is being shown as the product of their prime factors, right? And the 90 also has been done in the same manner. Then in order to find the HCF of the two numbers, notice how we have taken the numbers of the lowest order, right now. So here what we have taken, like we have taken those factors which are less in number. Like in these two, only 1 2 has been taken here. Okay. Then in these two, 3 is one time, and here 3 is repeated 2 times. So we'll be taking just 3 for the one time, not 2 time. Getting it, guys, what I'm trying to say. So we did took that 3 over here, and 5 is repeated here for the same time. So thereby 5 is also taken here. So thereby the HCF was 2 times 3 times 5, that becomes 30. So like this, let us do some more questions. Okay, now. So these were the questions which we did in the previous class. Don't focus at them. Let us do some questions on this once again. So I'm giving you two numbers. The first number is 45. Another number is 65. You guys have to find the LCM. Sorry, HCF, I mean to say. So the first one, let me do this one. Or you guys would like to do this one, the first one, this question? Is my screen stucking? Am I clearly visible?
Yes.
Okay. So 45, how can you write down it as the product of prime numbers? You guys have learned about prime factorization in the previous class. Like a number, you have number like 18. So 18 can be written as 2 times 3 times 3. All of them are prime numbers. So you have to write down 45 also as the product of prime numbers. Yes. You are
5
saying
9 are
5,
45.
but 9 is not a prime number, no? It's a composite number. You have to write it in the form of a prime number. So may, are you getting these concepts? You're not saying anything in the class?
See, but then my voice is not coming very properly.
My voice is not coming properly. Habib?
No, my voice does not come.
No, no, right now you're audible properly. Okay.
No,
I can hear.
before I said it didn't get.
Okay, I'm doing the first one for you guys. See, 45 can be written as 5 times 3 times 3. 5 threes are 15, 15 threes are 45. All of them are prime numbers. Okay. Hmm. Furthermore, 65, how can you write this? You can write this as 5 times 13. Getting it, guys? This is how you can write it down. So thereby, what do we find over here? That the only number that is common in both of them, we take the common factor now. We have to take the common factor. The full form of HCF, what is it? It's the highest common factor. It's the highest common factor. So which is the
Yes.
factor common for both of them? Only 5 is common now. Getting what I'm trying to
Yes.
say? So thereby the HCF of these two numbers is 5. HCF of these two numbers is 5. Okay.
Okay.
Let us take one more number. Give me a moment. Let us solve some more questions. So you have to find HCF using prime factorization. So I'm writing down some numbers. We have to find it out using the prime factorization method. So question number 1, Habib, you will be solving question number 1. You have the number 36 and you have the number, let us take another number. Let us take 48. Okay. Sumaya, you will be solving question number 2. You have the numbers as follows. You have the number 32 and 68. Okay.
Okay.
You know what you have to do. First of all, you have to show them as the product of prime numbers. Okay. Then after that, solve it.
I have to do question 1.
Yeah. you'll be doing some more questions on this. Usually, I observe that you guys need to practice more questions. And also, by the way, Habib, as I was checking your assignment, I found out that when you were solving the questions on LCM, now you had to find LCM by prime factorization method. There you have done lots of mistakes. You have done lots of blunder in that. So we would be visiting that concept, doing questions on that topic once again. Okay.
Okay.
And Sumaya, you haven't been uploading your assignments. You haven't even uploaded any assignment in the previous 2 weeks, I think. In the past 2 weeks, you haven't uploaded any assignments. Why? Yes, Sumaya?
I don't get the homeworks.
You don't get the homeworks. You okay, see the assignments are uploaded on the website after the class. The assignments are uploaded on the website. So from there you can get the assignment.
Okay. Which website is it?
Okay, okay. You don't know about that. I will be asking the team to share you the website link. Okay, no?
Okay. Okay. Sir, is 4 a composite number?
Of course, four is a composite number because it has got more than two factors, 1, 2, and 4. Yes, anyone of you done? Yeah, Habib or Sumaya?
Sir, I got HCF 8.
8. No. How can that be H? If you're solving the first question, no?
What?
No, that is not correct. Yeah, Sumaya?
Pics are almost done.
Okay. Habib, your answer is not correct. Answer which you have given, that is not correct. Okay. Let me
Sir,
help
no,
you
no.
solve the first question.
12. 12.
Yeah, that is 12. Very good.
Yeah,
Now it is
12. I
correct.
put.
Now it is correct. Okay, now. Okay, so may you also look at the first question? I'm solving this one. Okay, now. So this can be written as 3 times 2 times 2, right? 3 twos are 6, 6 twos are 12, and 3 and 2, both of them are prime numbers. Okay. And this can be written as 2 times 2 times 2 times 3, right? This can be written in this manner, isn't it? And also you can check whether this is correct or not. What is the product of this? 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 3, 48. So thereby it is correct. We have written this in the correct form. Now find out the common factor. Okay. So 3 is a common factor. Okay. 2 is a common factor. And once again 2 is a common factor. So thereby the answer would be, circle this one also. So the answer would be 3 times 2 times 2. That is 12. That is the HCF of the two number, which you have found out using the prime factorization method. Likewise, Sumaya, you are solving question number 2. Meanwhile, Habib, you solve question number 3. Yes. Sumaya, you done? Yeah, Sumaya, by now you should be done. Don't take this much time. If you're having difficulty in solving it, please let me know. Sumaya, am I not audible to you?
It's coming a little bit of lagging for me.
It's lagging for me. Have you got the answer of question number 2?
Yes, now I got it.
Yeah, what is the answer?
For me, the answer is coming 48.
40?
8.
48? No, that cannot be the answer. Okay, na? Usually HCF is always lesser than the given numbers. Like 12 is lesser than 36 and 48. Okay, now here also it would be lesser than both of them. Okay, now let us do it together. So 32 can be written as 2 times 2, then again 2, and again 2, again 2, and then again 2. So you found it out that 2 times 2s are 40, 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So we have written,
Basically write the number in the 68. I should have write 68, but then I write 48.
okay. Okay, no worries. Be careful next time, okay? For 68, how can you break it down? You guys have to answer this. Yeah.
So,
Hmm.
I got HCF 2.
HCF, how much?
2.
2. Okay, I will be checking that in a minute. Yeah. Sumaya answered this 68. How will you show it as the product of the prime factors?
After I did prime factorization of the
Hmm.
68.
Yeah. What have you
Okay.
written?
Okay, I will see this.
Yes.
Wait, I'm writing.
Not in the chat box. In the class. Do tell me in the class only.
Yes, I'm writing first in
Okay. You haven't written it yet. Okay. Write it quickly. Meanwhile, let us do this question for 56. What is the form? What have you written here, Habib? 56 is the product of. Hmm? Yes, hello,
Yeah,
Habib.
I'm checking.
Okay.
Okay, sir.
Hmm.
The for me, it's 2 and 17 factorization.
Very good. So that is 2 times 2 times 17, right?
17.
Very good.
Yes.
So thereby the common factors are this 2 and this 2 only, right?
Yeah.
And 17 is not a common factor. So thereby the HCF would be simply product of these two numbers, that is 2 times 2, that is 4. So 4 is the HCF of the number 32 and 68. Got this now? Okay.
Yes.
So you
Sir,
have solved this very good.
I wrote 1 into 2.
1 into 2, just 1 into 2.
Yes.
So is 1 into 2 equal to 56, Habib?
No.
No. So how can this be correct? See,
I
whenever
mean,
you hmm. See, let me clear this point. All of you, both of you, listen carefully. Whenever you do prime factorization of a number, make sure that you cross check it also. Like here, I have written the prime factorization of 32 like this: 2 times 2 times 2 times 2 times 2. Hmm. So, and the product is giving me 32. When I multiply 2 5 times, it gives me 32. When I multiply 2 with 2, that is 4. 4 with 17, that is 68. So you can check it in that manner whether you are doing the correct, whether you're doing it correctly or not. Okay, Sumaya, you solve question number 4, that is 20 and 48. Okay, solve it quickly.
find that one.
Yeah, you have to find that one. Now coming to your question, Habib, solve it again, Habib. Do prime factorization of 56 once again. Yes. Habib, what is the prime factorization of 56? Quickly answer this.
Sir,
Yes.
done.
Yeah, what is the answer?
HCF of 20 and 48 is 4.
4. Okay, I will check it in a minute. Yeah, Habib, done for question number 3 or not? You are not even replying.
No.
Not yet? Okay, solve it. For question number 4, it is 2 times 5 times 2. Like this, we can write it right now. Or better, it would be we can first of all write 2 and then 5. So
Sir,
2 times 2, that is 5.
Sir,
Yeah.
but I write 2 times 10.
No, then that is not correct because the prime factorization says that you have to show the number as the product of the prime numbers. Here 2 and 5 is a prime, all of them are prime numbers. But when you write it as 2 times 10, 2 is a prime number, but is 10 a prime number?
No.
No. So how can that be correct?
Sir, I
Okay.
got HCF
Hmm.
28.
28. I am afraid that is wrong, Habib. Okay. I'm coming to your question in a minute. Meanwhile, you also look at the solution of question number 4. Okay. Now 48, you can write this as this. Like normally, first of all, what you guys do now, 48, how can you simply write it down? Tell me, without worrying about prime numbers. 12 fours are 48. Like you
Yes.
can simply write this as 12 times 4. Okay, now? Okay. But none of them are prime numbers now. Neither 12, neither 4. So further, 12, can I write this as 3 times 4? And 4, can I not write this as 2 times 2?
Oh, 4.
Yeah. And all of them will be multiplied with each other also. But the problem is still we are having this number 4, which is not a prime number.
Uh,
So further, can I not write it like this 2 times 2?
Sir, I'll go to washroom. Okay, wait.
Okay, okay. Okay, let Sumia be back. Yeah, Habib, about question number 3, you're answering 28. See, the problem is you might not have done the prime factorization properly. See, it can be written as 7 times 8. 8 can be, how can you write 8? Can't you write it like this? 2 times 2 times 2? Yeah, Habib?
Yes.
So we can write this like this, okay? That's the prime factorization of 56. Match it with yours also. Did you did it the same way or another way?
I got like 28 to the.
See, that's the problem, no? When you write it as 28 times 2. Did you not
Yeah,
read this topic? Here it says prime factorization, no? So you have to write only
yeah,
prime
I did
numbers.
that. I got 7 into 2 into 2 into 2.
Okay, good then. Earlier you said you have written it as 28 times 2. Thereby I thought you have done it wrong.
I did 28. Now I changed it. I did
Okay,
7 into 2. What do you think?
okay, okay, good. Now 84, normally you can write it as 42 times 2, but the problem is 42 is a composite number, not a prime number. So let us break it down. How can you write down 42?
Um,
How can we write down 42? Like further, do tell me, can't you write it as 21 times 2, right? But
yes.
still we are having 21. That is a composite number. So how about I write 21 as 3 times 7? Right, now the problem is solved. So 3 times 7 is 21. 21 twos are 42. So therefore 42, I can write it like this. I can write the number 42 as 3 times 7 times 2. And there was 2 which we have written before. So did you write this number? Please let me know.
Yes.
Good then. So let us find out what answer we would be getting. Let us see. So first of all,
fourth question, the fourth one.
Yeah. Actually, you were not in the class, so we are doing the question number 3. We'll be continuing with question number 4 in just a minute. Okay. You also look
Okay.
at question number 3, Sumaya. So 7 is a common factor. Okay, and this 2 is also a common factor, right? Only these two are common in both of them. So thereby simply multiply them. 7 twos are 14. Got this, no?
Right.
7 twos are. By the way, just 1 minute. There's one more too, actually, no? Yeah, just this one also, no? We did forgot about this too. Yeah, okay. In that case, then your answer is correct. Good, Habib. So 7 twos and then again twos, that would be 28. Both of you got this? How we found out the answer for question number 4? For question number 3, I mean to say.
Yeah.
Talking about question number 4. So here we have broken it in its prime form, prime factorization. So thereby it was, we had to write it in this manner, no? 2
Sir,
times, yes,
my HCF for me is coming 60.
60, 60.
60.
Okay, 6. Okay, I will be checking that in a minute. Okay, so that is 2 times 2 times 2, 2 times 3. We can check it out also whether it is giving you back 48 or not. 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 threes are 48, right? So that is correct. Now we are required to circle the common factors. This 2 is common and this 2 is common. Only 2 twos are common here. Getting it now? No other numbers. So thereby simply find out their product, that is going to be 4. Understood this one, Sumaya? 16 is not
Yes.
correct. It's 4. Okay. So
Okay.
is this topic clear to both of you, how you can find out HCF using this method, using the prime factorization method?
Yes, it's clear. Yes.
Okay, na? Okay. Let us do one more thing. How about we take some more numbers? I'm giving you guys one more question to solve. Then we'd be continuing with the next method. So you guys take a number 390, 702, and 468. I'm providing you with 3 numbers. Okay. So find out their HCF using the previous method. Okay.
So this question
Yeah,
is
this
for whom?
question. Both of you, both of you.
It's very hard.
No, I don't think so. It's that difficult. Hmm? In a step wise, you can solve it quickly. Like think of the number 390. So how can you break it? Like first of all, break it into 2 parts. So what is the half of 390? That is how much?
I'm doing.
Okay, both of you find it out. First of all, look out for from which number it can be divided. It can be broken as the product of which 2 factors. Okay, now it can be broken as the product of which 2 factors. Yeah, first of all, you guys answer me. How you have broken the number 390?
So, how do we do? 39 into 5 into 5.
No, you could have written as 39 times 10. You could have written it in that manner.
10, 10 is like not, 10 is composite number.
See, furthermore, we are going to break it down. Like 39 is also not a composite number. This is not a prime number, it's a composite number. Hmm?
Hmm.
So you can first of all break it down as 39 times 10. Very easy. 39 times 10, that is 390. Yeah, Sumaya
30,
and Habib.
39 has more than 3 factors.
Of course, it has more than two factors, in fact, more than three factors, but right now we are not done yet. No, we are going to break it down further also. Okay. Now, do tell me, how can you break down the number 39 further?
So, in which table 39 comes?
Read the table of 13.
13 threes are 39.
Exactly. So 13 threes are 39. Sumaya, you getting it now? We have to,
Yes.
you guys have to pay attention here. And furthermore, 10 can be written as
Uh, 10 can be written as 5 into 5. 5
5
twos
into
are.
5. 5 twos are
5
no.
twos are.
So 2 fives are 10, right? Okay, so now we have the prime numbers now. 13 is a prime number, 3 is a prime number, 2 is a prime number, and 5 is a prime number. Okay. So the number 390 is still, it is the product of numbers like, first of all, write from the small number. 2 times 3 times 5 times 13. Getting it? That is the prime factorization of 390. Okay now? And you can cross check it also. How can you cross check it? Simply multiply all of it. 2 threes are 6. 6 fives are 30. 30 times 13 is how much? When we multiply it out, thereby we would be getting the number 390. So yes, I'm getting back this number. So my method is correct. My numbers are correct here. And in fact, all of them are prime numbers. So yeah, we are going in the right direction. All of you understood how we have to do this now?
Yes. Yes.
Okay, for the second other two numbers, I will not be answering. You guys have to solve it yourself. Okay, do it quickly. Do it as soon as possible.
So, I got next one also.
Next one also very good. Okay, make sure that all the numbers are prime numbers. Okay, and as the product, you are getting the number 702. Okay, yes, Sumaya, you are doing the question now. I'd be giving you a hint for the second number 702. What you guys can do, let me first of all erase this one.
351 into 2 is equal to
Exactly.
702.
Very good. Very good. Right now. But furthermore, also you have to break down. But we can
That you have
continue
to
to
break
divide.
down 351.
Exactly. Okay, na?
Sir, I guess I got the answer.
Yeah, that's good. What answer you're getting?
For me, it's a 7. But it's a 78.
78. Very good. That is in fact correct. That is correct. By the way, that is correct. Very good. Okay, no? Okay, what are how you guys have broken down the number 702? Yes, Sumaya, how did you broke it down? What are the prime? What is the prime factorization of 702? Answer this.
Prime factorization, right?
Yeah, of 702.
Okay, wait. I will explain. Wait, first let me see what I'm right first.
Okay, you must have written the prime factorization of
Yes,
702.
I have right the
Okay,
prime
okay.
factorization.
Okay, okay. Have a look at it. Then answer.
Yes. Okay, so first I break it down 702 into 2 and 351.
Very good.
Then for the 351, I did 3 and 117. Then
Very
for
good.
117, I did 3 and 39. Then for 3 and 39, I did 339. I did 330.
Just for 30, just for 39, you have written 3 and 13.
30.
Very good, very good. That is the method. Have you done the same thing, Habib?
Yeah, but I don't understand how to do 468.
Okay, that one is also simple, not that difficult. We'll be able to solve that too. So let us write down the prime factorization of this number. There is 2 times, 3 times, 3 times, and again 3 times, right?
13.
Then 13. Good. Talking about the number 468, that can be also done easily. Yes, Sumia, what have you written first of all? First of all, let us write it, break it using the smallest prime factor, that is 2. Okay, now that is 2 times 234, right?
Yes. Sir,
234.
I got
Yes,
78.
78. Very good. That is correct, in fact. Very good. So that is 2 times 117. 117 can be further written as 3 times 39, and 39 is 3 times 13. So here the prime factorization of this given number is 2 times 2 times 3 times 3 times 13. Okay, we
Sir,
have to
break the numbers.
yeah, we have to take the numbers. The first of all, take 2. 2 is a common factor of all of them. Good. After this, we'd be taking 3 now. This 3. And after this, you will be taking which number? Yes, both of you answer it quickly. Which is the next number, which is a common factor of all these 3 numbers? Is 5? No,
13. No, it's not 5.
it's 13, no?
13.
Exactly.
13.
Very good. So
Then we have to
thereby,
multiply those all.
exactly. So the HCF would be found out by multiplying these common prime factors. 2 times 3 times 13. So 2 3s are 6 and 6 13s are, or 13 6 are 78. So that is your answer. So it was an interesting question and not that much difficult. Hope you guys have understood this, right?
Yes. Yes.
Okay.
Yes.
So that's it for today. Or we have Okay, this time is almost about to be over. But before that, how about we do some learn interesting things in today's class? The topic HCF has been finished here. We'd be learning about one more thing. Okay, now let us conclude the class by learning one more method of finding the HCF. It is by the division method. So in the example given here in the slide, we have the number 198 and
Sir, there is
360.
just 1 minute to end the class. And
We can extend it to 1 or 2 minutes extra. No worries about that. Okay. So 198 ones are 198. We have taken a number smaller than 360 because 198
Sir,
twos would be 396. Yeah.
but sir, but my brother has a class in the same day.
On the same link.
Yeah. No. In this, my brother has a class at 8 o'clock.
Okay. Okay. Then let us.
Sir,
Okay.
I
All
also
right.
have to go to Salah.